All right, students, so let us continue with the syllabus, okay, for our chapter 3 Trigo. Right, so in the previous video, we already discussed how to sketch the graph for secant, cosecant, cotangent. All right, and then you also learn how to solve the very basic equation that involve cosecant, secant, and cotangent, right? Okay, so from this video onwards, we are going to discuss all the identities that involve in Trigo. All right, so there are 4 sets. To me, I think there are 4 important parts here. Okay, so for learning outcome 3.2, we are going to learn all the identities or all the important parts, 4 important parts. And for all the identity here, you actually need to use it to maybe solve the equation. You also need to actually learn how to prove, okay, the equation correctly by applying the important identities. Right, there are 4 sets of them. The first one is the Pythagorean identity, okay, which will be covered in this video. Okay, then the second one will be the compound angle formula, and after that it is double angle formula, and finally we are going to express a sine theta plus b cos theta in a sine or cos form. Right, so there are 4 different parts here, so we'll separate it into 4 different videos or more, right, to discuss all the importance for all the identities here. All right, so I believe that most of you learned it before, okay, but for maybe A2 syllabus, you need to know how to apply it correctly to answer the question or maybe to solve the equations, right? Okay, so please take note that all the identity here, quite a number of them will be involved or maybe will be combined with integration later also. All right, so if possible, try to memorize all the identity here, okay? Instead of finding the formula booklet to get the formula. All right, because to me, if you can memorize all the identities, it will be much more easier for you to attempt when you want to attempt the integration question. All right. Okay, so let us start with the very first one, the Pythagorean identities. So the Pythagorean identities, right? Basically, it is the basic one. We learned it before already, which is sine square plus cos square equals to 1. Okay, so this is something that we learn in AS level. And then there are another 2, which is 1 plus tangent square equals to secant square. Another one is 1 plus cotangent square equals to cosecant square. All right, so you need to think a way to memorize it. So in maybe from internet, when you search for it, you will see that there are a lot of methods to teach you how to actually memorize this set of identity. We call them as Pythagorean identity. Okay, so for me myself, how I memorize it is basically I only memorize one. I only memorize sine square plus cos square equals to 1. Okay, so this is the original equation that I memorized. All right, so now how can I get the second equation, which is 1 plus tangent square equals to secant square? Generally, what is I remember, okay, maybe I divided the whole equation by using sine square theta. Therefore, when you're having sine square theta divided by sine square theta, it becomes 1. Then plus, when you're having cos square theta plus divided by sine square theta, cos over is cotangent, right? And therefore, you're having cotangent square theta. All right, and after that, equal sign 1 divided by sine square. So 1 over sine is cosecant. Therefore, when you're having 1 over sine square, it will become cosecant square theta. So you can that this is a third identity for the Pythagorean identity set. All right, so this is how I memorize it. Of course, there are a lot of different ways for you to memorize it. Okay, all right, then how about for the second equation? How can I get this second equation here? Okay, so the same thing, just now you divided by sine square, right? So now you can divide it by cos square theta. All right, so let us start. Sine square divided by cos square, you get tangent square. So tangent square theta plus cos square divided by cos square, you have 1 equals to 1 divided by cos square. So you have secant square. So that's why you get the second Pythagorean identity here. All right, so this is how we get all the 3 identity from the original one, which is sine square plus cos square equals to 1. I believe most actually can remember this, right? Okay, so this is how I memorize it. Okay, as a reference for you, if let's say you have a better way to memorize it, then just go ahead and use your method. All right. Okay, so for the proving part in detail, they actually want to show you how you get the identities here. So I'm not going to discuss this with you. So if you're interested, you can have a look for the proving part. All right, so all the proving part are quite detailed, so I hope that you have an idea how to do it. Okay, so I don't want to discuss this with you here. Okay, you have a look. Okay, so usually for all the identity here, they will involve in different types of question. So you might have proving question like this, example 6, all right, or maybe you are having the solving equation question. All right, so what I can tell you is most of the time, not exactly every time, most of the time when they ask you to prove the identity, right, they will usually combine it with integration, or maybe they will combine it with solving equation. Usually the proving part won't come itself. Usually it will combine with some other things. Okay, but for here we are going to start with example 6. Start with the two example, proving example first. Okay, so same thing that I want to say. For all this proving question, the only method, the only way that you want to improve your skill in proving question is you have to try a lot. Don't feel worried that you didn't get the answer, or you don't feel scared to start writing out something. But you just need to make sure that you really try. You really try to prove it, and then try and see to figure out how to get the answer that they want. Okay, so you have to really try. If you just read the solution from your friend or from maybe some internet solution or whatsoever, right, you actually learn nothing from here, and you won't improve your skill improving. Okay, right, so let's start. For part number 1. Okay, so for part number 1, should I start from left or right hand side? So for me, I'll start from left. So what's the reason that I want to start my proving from the left hand side? It is because of right hand side, the trigo looks more simple. More simple in the sense that I'm having sine and cos, which is very simple. If you look at the left hand side, you have tangent, cotangent, secant, cosecant, right? So generally, you can still simplify all this into sine and cos, correct or not? So to me, right hand side is more simple pattern. Left hand side is more complicated. Therefore, I will start from left hand side. Okay, so start from left hand side. This is what I have: tangent theta plus cotangent theta. Okay, divided by secant theta plus cosecant theta. Alright, so because my answer on the right hand side, they involve only sine and cos. Therefore, my next step is I will want to try and change all my identity here, become sine and cos only. So what is tangent? Tangent is sine theta divided by cos, right? Okay, then plus, what is the cotangent? So cotangent is cos divided by sine. Okay, how about secant? So for secant is 1 over cos. How about cosecant? It is 1 over sine. Okay, so I hope that you so far understand what am I doing until this step. Okay, so all these are separate fraction. It is fraction inside fraction. All right, so to simplify these fractions, what am I going to do? I think I need to combine them, become one fraction on top first. Right, so how can I combine them? Okay, so again, when you want to combine two terms on top, you have to change it to become the same denominator. Maybe wait, I'm not having enough space. So maybe I may write like this. Okay, so I have to change it become the same denominator, right? So I'm having sine theta cos theta. You multiply the denominator together. So on top you're having sine square theta plus cos square theta. And then at the bottom you will have sine theta plus cos theta divided by sine theta cos theta. So I combining the fractions become 1 respectively for the numerator and also the denominator. Okay, and after that, to simplify it, okay, so it will become sine square plus cos square divided by sine cos. Okay, multiply with sine theta cos theta divided by sine theta plus cos theta. Okay, so if you don't know how I get this, just think again last time when you learned. If let's say I'm having 7 over 3 divided by x over x plus 1, how can you simplify it? It will become 7 over 3 divided by x plus 1, right? Then you have to change it, become multiply, which is x plus 1 over x. So this is the same concept that we learned before. Okay, right. Then after that, you can simplify a lot of things here, right? So you can simplify the sine theta, cos theta with this one. And then you know that all this whole equation is equal to 1 from the identity that we learned as level. And eventually, of course, you can get the answer that they want you to show, which is 1 over sine theta plus cos theta. Okay, so I hope that you can get what am I saying here. Right? Okay, so this is what we have. Okay, so for those who are interested to try, you can try part number 2, but generally part number 2 is quite hard. Not to say quite hard, most of the students, right, they can't really think of the proper way. Okay, but actually this question, the solution is quite short. Okay, I also learned this short method from my previous students. Okay, so again, if you look at the part number 2, for me myself, I will study from the left-hand side also, because in my opinion, the left-hand side is a fraction. Right-hand side is there are 2 terms here. So to me, when you are having a fraction, it is more complicated than the simple 2 terms. All right, so again, I will start from left-hand side. Okay, so 1 divided by secant theta minus tangent theta. All right, so there are many ways for you to solve it, or to prove this equation. But to me, in my opinion, the easiest method will be what I've shown you now. The method that I'm going to show you now, right? So for the 1 here, because I see that, okay, my equation got secant, theta, and tangent. Then the right-hand side also got secant, theta, and tangent. So I would think, is there any formula related to these 2 trigo? All right. So if you still remember, we learned 1 trigo before, right? So which is 1 plus tangent square theta. It is equals to secant square theta, right? Okay. All right. Then now I would like to change this equation become 1 equals to secant square theta minus tangent square theta. And eventually, what do you get? Okay, so you can substitute this into the 1. All right. Okay, so I'm having secant square theta minus tangent square theta divided by secant theta plus tangent theta. Okay, so next, how can you simplify it? For the numerator on top, you can expand it actually, or you can factorize it. So let's say factorize, I think it should be factorized, right? You can factorize it become secant theta minus tangent and secant plus tangent. Okay, and then divided by secant theta plus tangent theta. Okay, maybe some of you will ask, how can you change this one become this? Okay, so we are using the idea that you learned before, x squared minus y squared equals to what? X minus y and also x plus y. All right, so that's why you can expand it, or you can factorize it, become something like these are 2 brackets. So the secant theta is like your x, the tangent theta is like your y. Okay, so you're having x minus y, x plus y. Okay, then from here you can see that you can simplify secant theta. Wait, is it something wrong? Oh, okay, so sorry, I know already. This one I make a careless mistake, right? Yes, this one should be minus. Okay, so minus here, this one should be minus here. So you can simplify only the minus one. Okay, so you should simplify the minus one, right? So simplify this and simplify this, and eventually you get the right-hand side expression that they want you to show. So you're having secant theta plus tangent theta. Okay, this is the shortest way that I can figure it out now. And this method I learned it from one of the students maybe a few years ago. Because usually when I teach this, last time when I will teach a very long method, then I find that this one is the shortest, right? So for the proving question, you're actually learning from time to time. All right, you thought that your method is the best one, okay? But actually maybe some of your friends will have the shorter methods. Okay, so this is one of them. All right, so I hope they understand what am I talking here. Okay. All right, so this is the questions that involve the trigo, okay, the Pythagorean identity in proving. All right, so we are going to continue to the next example. So again, for next example, it involves the solving the equation. Okay, so for solving equation, right, you still need to use all the concept that you learned in AS before lah. So again, what am I doing is I'm still referring to the 4 quadrants one. Okay, if let's say got positive or negative one, I will still refer to it. All right. And then for me, I also lazy to draw out already lah. So you can refer it back, okay, to all the 4 quadrants graph that I shown you before. Okay, so I will just show you the details here. All right, how are we going to solve? Okay, so first part, 7a. Okay, they want you to solve this equation, cotangent square theta plus 5 cosecant theta plus 1 equals to 0. And then the answer that they want is from 0 until 360. Okay, so now, if you are having cotangent and cosecant at the same time, you cannot solve the equation. You have to try to change everything in one type of trigo only. Alright, so you need to change everything in one type of trigo. So maybe you can focus on cotangent square. Cotangent square, you can actually change it become cosecant square minus 1. Alright, so this is cotangent square theta, and this is cotangent square theta minus 1. Okay, and then plus the cosecant one is still copied, nothing special, and then plus 1 equals to 0. Alright, so if at this, when you simplify it, you will see that you actually get a quadratic equation in terms of cosecant theta. And then this quadratic, I think, is still very simple because you can factorize it in a very easy way. Alright, and after that, you will have 2 equations here, cosecant theta equals to 0, and you need to ignore it. Okay, because you won't get any solution from here. Why you cannot get the solution from here? Think it on your own. All right, think on your, by yourself. So please make sure that you know why it is equals to 0. Then you need to ignore. Okay, don't just simply copy. All right, so you try. Okay, why do I need to ignore this part? Okay, then the other part will be cosecant theta equals to negative 5. So cosecant theta is negative 5 means that 1 over sine theta is equals to negative 5. Okay, so if you continue further, that means sine theta will be equals to negative 1 over 5. So from here, please try to solve the equation that you learned in AS level before to get the answer. Of course, you need to go through the quadrant now. You need to find the basic angle and everything. Okay, so for me, I'll find the basic angle first. So what is the basic angle here? Okay, so for basic angle, what I get is 0.201. And then when I go through the 4 quadrant, right, because they want sine negative. So sine negative should be in the 3rd and 4th quadrant. So if you go through the 3rd and 4th quadrant, you should get 3.34 and also 6.08. Okay, so if you don't understand how I get these 2 answers, please refer back to the AS labels that we learned before and take this chance to revise your AS level trigo also. Okay, so I'm not going to repeat everything here in details anymore because you should go and try to figure it out yourself because we learned it before. Okay, so this is what we have for part A. All right, so you can see that the main idea is you need to change the equation into the equation that's with only one type of trigo. That only you can solve it. All right, okay, after that we go for part number 2, part number B. Okay, so for part number B, again, you're having one equation here. This is the equation given. All right, so again, you're having theta and tangent square theta, which means you cannot solve it straight away like this. So you have to think how to change it become one type of trigo. So tangent square theta, you can write it become secant square theta minus 1 if you follow the trigo identity that we learned just now. Okay, and therefore when you look at it, okay, now the whole thing become with only one type of trigo in the equation. All right, so if you continue further and try to simplify it, you should able to get 2 secant square theta minus secant theta minus 6 equals to 0. All right. Then you can try to factorize it. So when you try to factorize it, right, you should have secant theta equals to -3/2. And after that, secant theta is equals to 2. All right, so which means it will become cos theta equals to -2/3. Then cos theta will get half. All right, so for this question itself, they are asking for the smallest positive roots. Smallest positive, that means your answer must be in positive. So which one is smallest, which one is positive, right? So no matter how, you just solve and get the two positive solution for both equations. Okay, so what is the answer for this part? So the basic angle for cos theta equals to -2/3 is 0.841. Okay, so this is the basic angle, which is 0.841. If you go through with the quadrant, cos negative means that you should get the answer from second quadrant and also the third one. Second quadrant and third quadrant will be 2.30 and also 3.98. Okay, so if you continue from here, cos theta equals to half. All right, so if you again follow the quadrants that you want, cos positive means that you need to have the answer from first quadrant and also the fourth quadrant. Okay, so how to get all this value, I'm not going to discuss it with you anymore because it is something that you should know earlier where you learned it from AS syllabus. Okay, then now you have 4 answers here, but for the final answer, they only want you to have 2 smallest positive roots. So you can press the calculator and see which values are the 2 one. So the first one is pi/3. The second one should be 2.30. So this is the final answer that you should show them. All right, in your steps. Okay, not showing for all the 4 answers, but you should show them 2 only. Okay, so these are the examples how we prove by using the identity and also how we solve the equation by using the identity. All right, so again, to make yourself familiarized with the whole process, the only way is try more questions and also the partial questions. There's no shortcut. All right, you don't tell me that last time I just memorized and then I just keep on doing the same type of question that I can answer. No, for A-level, the question style can be very different from year to year. So make sure you try as many questions as possible. All right, to familiarize yourself with all the question patterns, or maybe you learn actually something new from different types of question. Okay, so this is what we have for the Pythagorean identities. All right, so we'll stop here for this video. Then the next video, we are going to discuss the second set of identity, which is compound angle formula.